Welcome to Brad's class, and thank you for taking some time to watch my video. I'm a high school physics teacher, and today I'm going to cover the most common physics questions that students usually ask me. They do ask me other questions, but I tend to try to deflect those and keep them based on physics. Question number one, I'm not going into the sciences. Why do I need to know physics? This is the most common question that I get. And here are the usual responses that I give my students. I tell students that they already have an appreciation for physics, even if they don't know it. The first thing I usually tell them is that anything using technology is using physics. So everything that they love, including cars and telephones and laptops and games, all those things require physics. The second point is that people make physics calculations intuitively. Think about if you're in a car. You're not actually making the calculations, but you are thinking about distance and time. For instance, if a car in front of you is really far away and they're slowing down or they're stopped, you gradually slow down because you know that longer distance you have more time to stop. However, if the person in front of you is closer, then you know your distance isn't as much. So what do you need to do? Press the brake harder and you stop faster. Okay? Now, you know the difference that you're going to feel between those two situations. So the point is, even if you aren't using pencil and paper, you are still using physics. The last thing is that physics teaches logic. Logic is also called creative thinking, critical thinking, whatever you want to call it. Now, logic is something that can be improved through practice, and physics is a perfect opportunity to do that. Also, logic can be used in almost any other situation in life. So it's a very practical benefit from learning physics. The second most common question, I'm not good in math. Can I do well in physics? The simple answer is you should have done well in algebra. However, the functions that we used in algebra-based physics are addition, subtraction, multiplication, division, square root, PEMDAS or order of operation, and factoring and distributing. So if you weren't that great in algebra, you can still do well with these basic building blocks as long as you're able to build on them. So what do I mean by using the basic algebra functions? Well, we do two types of things primarily in physics. The first is called isolation. That's where we take a variable and we move everything away from it in order to solve for it. The second one is substitution. That's where we take a variable and put either a number or another function in there in order to solve for the problem. So we're basically using this simple algebra functions and we're doing isolation and substitution in order to solve for that. The next question I get is, what makes physics hard? And other than the math, which I just explained about, I've divided this up into three separate parts. So the first point is that physics deals with forces which can only be felt. So whenever we're solving a problem in physics, we're taking a moment in time or a picture. Now think about if you look at a picture. You can't tell what forces are on that picture. You don't know what magnitude or the amount of the force. All you can see is the effect of forces. So when you talk about something that can only be felt, sometimes pictures can be misleading. So this means that sometimes students have misconceptions and people in general that are hard to break. In other words, if you think something is going to happen because you've seen it all the time, and I told you, forces can only be felt. So if you're looking at it, you may believe that it works because of some reason that it really doesn't. So these misconceptions are really hard to break. Now, sometimes people say seeing is believing. However, I have a video that I'm going to show you which shows you that seeing isn't always believing. This video is from YouTube and it looks like that M is three-dimensional. However, it's really only two-dimensional, as you saw from that pencil going through. So this person actually draws this out and cuts it so that when you look at it, it looks 3D, but it's actually not. If we go to the end of the video, you can see him move the camera angle and it still looks 3D. However, it's been cut out from a two-dimensional piece of paper. So this indicates that what you see is not necessarily what it actually is. So let's go on to the second thing that makes physics hard. In physics, changing one variable can change how to solve an entire problem. Why does this make physics hard? Because students are used to solving something in a very specific way. In other words, if I give a student a problem and gave them another problem that was similar to that, they could easily solve it. However, once you change one variable, it can change the entire procedure with how to solve it. This means that when solving a physics problem, students are going to make mistakes. Sometimes that mistake means going all the way back to the beginning and restarting the problem. And what I've found through teaching is that students don't like to do that. So, this is another thing that makes physics hard. The last part, what makes physics hard, part C. This isn't necessarily a problem with students, it's a problem with how they were taught their previous sciences through memorization and one-step answers. When it comes to physics, memorization has to be replaced with understanding concepts. And one-step answers, it's a series of one-step answers. That's really how I try to get students through physics. You solve one step, which leads to something else. So in essence, they're not one-step answers. However, each of the multiple parts of the answer require one step at a time. So if you combine A, B, and C, these are the challenges teachers face when they're trying to teach physics to students. Now usually on the second or third exam when we're covering Newton's laws or displacement, velocity, and acceleration, if a student finds out that they're not doing too well in my class, they always ask what other resources are out there. Here I've listed the most common ones. Khan Academy, he's very well known. He does a really good job teaching individual topics in physics. YouTube is an excellent resource. You can always look at professors actually teaching this in some of the bigger universities, MIT or Stanford. Physics Classroom is a very basic site that I like to use. It has really good information and questions that have answers on it. And of course, the last step is one-on-one tutoring, and there's a bunch of sites out there. Now, I've tutored people before, and it works when you're trying to answer one-on-one questions. For instance, if you can't solve a particular problem, tutoring's great from that. However, tutoring, in my opinion, really depends on the relationship between the tutor and the student. The better the relationship, the more the student can understand. So I'll be developing a physics class for algebra-based high school physics. I'll be presenting more information in later videos, but that is something to keep an eye out for. I hope this video brought to light some of the questions that students have asked me over the years that I've taught in high school. Thanks for watching.